This video is on Chapter 10, Hypothesis Testing, Basics of Hypothesis Testing, or Language of Hypothesis Testing. Null hypothesis H0. Null hypothesis is always denoted by H0. This is the statement of zero or no change. That simply means nothing has changed from what was observed in the past. If the original claim includes equality, it is the null hypothesis. If original claim does not include equality, equality means it could be less than equal to, greater than equal to, or equal to. If it does not include equality, then null hypothesis is complement of original claim. The null hypothesis always includes an equal sign. Keep in mind, it's always null hypothesis H0 either has a less than sign, less than equal to, greater than equal to, or equal to sign. The decision is based on the null hypothesis. We either reject the null or fail to reject the null. We start with the assumption that null hypothesis is true. Okay. Alternative hypothesis is denoted by H1 or HA or sometimes H alpha as well. Actually not H alpha, it is H1 or HA. Statement which is true, so this is a statement which is true if null is false. The type of test, so whether we have a left-tailed, right-tailed, or two-tailed test is decided based on the alternative hypothesis. So alternative hypothesis decides if you have a left-tailed test, right-tailed test, or two-tailed test. Remember, one thing that is really important, this is where sometimes students make mistakes, that both null and alternative hypothesis come from the population, not from the sample. So keep in mind they both come from population, not from the sample. Okay. For example, the mean weight of airline passenger is at most 195. The word at most has equality sign in it. So that's going to be my null hypothesis. And the complement, so what is at most 195? At most 195 means less than equal to 195. So I could also write H0 as less than equal to 195. H1 would be greater than 195. Okay, and this is our claim in this case. Our claim could be the null hypothesis or the alternative hypothesis. Either one of those can be the claim. Okay. H0, the null hypothesis, simply means there's no difference between the sample mean or proportion, and I think there's some repetition over here. The difference is zero. That's what null hypothesis says. Alternative hypothesis is the complement of null hypothesis. So you first have to also decide which one is the claim in your problem. After you have determined which hypothesis the sample supports, you make a decision. There are two options for a decision. We either reject the null or we fail to reject the null. Reject the null or fail to reject the null. Okay. Next page. H0 always has an equal sign, greater than equal sign, or less than equal sign. HA, so if this is really important to keep in mind, if H0 has equal sign, HA will be not equal to. If H0 has greater than equal to, HA or alternative hypothesis will be less than sign. If H0 is less than equal to sign, HA will be greater than. Again, to keep in mind, H0 always have the equal sign in it. It could be equal sign, greater than equal to, or less than equal to. Okay, here's an example. Research question. Is the average monthly rent of a one-bedroom apartment in State College, Pennsylvania, less than $900? Now, if you look at this $900, less than $900, This one does not have equality in it. So this would be our alternative hypothesis because there's no equal sign in here. So that would be our alternative hypothesis. So we're going to say HA is mean rent, average monthly rent. That average tells me it's a mean problem. So I'm talking about the mean is less than 900. For H naught, I actually have two different options. I can say it's greater than equal to 900, or I can just say it's equal to 900. Both options are correct. Okay. Next example, we have IQ scores. Is the average IQ score of all World Campus Stat 100 students higher than national average of 100? Again, higher than 100. First of all, we want to decide if it's a mean problem or a proportion problem. Well, it is going to be a mean problem because we're talking about the average IQ. Now, so the claim in this problem says higher than 100, so that means my alternative is the claim in this case. Null. So null has two options. I could say the H naught is mu less than equal to 100. That was another option for H naught. We also need to remember that alternative hypothesis decides if you have left tail test, right tail test, or two tail test. Left tail test, right tail test, or two tail test. Two-tailed test. Okay, so if I look at this alternative hypothesis, I can tell it would be a left-tailed test because it's less than left-tailed test. If your alternative hypothesis here is greater than, it would be a right-tailed test. Right-tailed test. Okay. Next example we have on the next page. It is about dog ownership. Research question. Do the majority of all Sutter Campus Stat 100 students own a dog? First of all, we got to decide if it's a mean problem or a proportion problem. And it looks like it would be a proportion problem. Because if I'm the researcher and I'm asking people this question, I will be asking, do you own a dog? And the answer would be yes or no. It would be not a number. If the answer is going to be yes or no, then it's a proportion problem. If my answer is going to be a number, then it's going to be a mean problem. So majority of all Yuba College students, so that means majority means more than 50%. Majority simply means more than 50%. So in this case, my claim is going to be alternative hypothesis. And that would also make it a right-tailed test because I have the greater than sign. Type 1 error is rejecting the null hypothesis when it is true, saying false when true. Usually it's a more serious error. Type 2 error is failing to reject the null when it is false, saying true when it is false. Suppose that you are a lawyer that is trying to establish that a company has been unfair to minorities with regard to salary increases. Suppose the mean salary increases per year is 8%. You set the null hypothesis. So here's your null and alternative hypothesis. One thing, it's not a part of this question, but we can see that it is going to be a left-tailed test. What is a type 1 error here? So what would be type 1 error? Remember, type 1 error is rejecting the null when it is true. So that means type 1 error is saying that the mean salary increase is less than 8%. So saying that this is not true when it was actually true, that would be our type 1 error. Okay, next we're going to look at alpha is probability of committing type 1 error, beta is probability of committing type 2 error. Test statistic is the sample statistic used to decide whether to reject or fail to reject the null hypothesis. So we're going to be dealing with proportion problems. For the proportion problems, our test statistic would be the z test statistic. And for the mean problem, we would have z or t, depending on if sigma is known or sigma is unknown. For standard deviation problem, we would have a chi-square test statistic. The formulas are on page 238 of our notes. So if you want to look at the formulas, we are going to get there soon. They're on page number 238 of our notes. Critical region is set of all the values which would cause us to reject H naught. Extreme values that would cause us to reject H naught. That would be critical region or critical values. Significance level alpha is probability of rejecting the null hypothesis when actually it is true. Alpha is usually used as 0.05, which is 95% confidence level, or 0.01, which is 99% confidence level. If no alpha is given, we would go with 0.05. The level of significance is complement of level of confidence in estimation. Decision, a statement based upon the null hypothesis. It is either reject the null at the end or fail to reject the null. We will never reject the alternative or fail to reject the alternative. Okay, we would never accept the null as well. We go with the assumption that null is true, and then from there we can either reject the null or fail to reject the null. Okay, conclusion would be a statement which it's more clear on the next page, so I'm going to take you guys there. Which two errors are more serious, type 1 or type 2? Type 1 is more serious, so we try to keep a smaller alpha so that we don't have a big probability of committing type 1 error. Okay. How to state your decision, very, very important. So if your original claim is H naught and you reject H naught, then there is sufficient evidence at that alpha level of significance to reject the claim. If H1 was your original claim and we reject H naught, then there is sufficient evidence at alpha to support the claim. If we fail to reject H naught and H naught was my claim, so this is really important. This is original claim is H naught, original claim is H1. So if original claim is H naught and we fail to reject H naught, there is insufficient evidence at the alpha level of significance to reject the claim. If original claim is H1 and we fail to reject H naught, there is insufficient evidence to that alpha to support the claim. Again, keep in mind, if we reject H naught, there is sufficient evidence either for H naught or for H1. If we fail to reject evidence, whether the claim is H naught or H1, we have insufficient evidence in both cases. All right. Next, types of tests, left tail, right tail, two tail. We already talked about. H1 or alternative hypothesis decides if you have a left tail test, right tail test, or two tail test. So if your H1 has a less than sign, you have a left tail test. If your H1 has a greater than sign, you have a right tail test. If H1 has a not equal to sign, we have a two tail test. All right. It solely depends on the alternative hypothesis. Okay, here's two-tailed test. So here's your rejection region, and if your critical value, if your test statistic lies in the rejection region, we would reject H naught. Left tail test, if your test statistic lies in here, we would reject H naught. If it does not, we would fail to reject H naught. So again, if your test statistic lies in the red region, reject H naught. If it does not, we would fail to reject H naught. Okay, here are the steps for hypothesis testing. The first step would be write the null hypothesis, alternative hypothesis, identify the claim. If your first step is not correct, then everything else will be messed up from that point onwards. So it's really important to give it a thought and then identify your null hypothesis, alternative hypothesis, and identify the claim. Okay. Hypothesis testing has, we do it in two different ways, traditional method and p-value approach. Right now, I'm only discussing the traditional method approach, but we will also talk about p-value approach. Second step is use the alternative hypothesis to decide if you have a left tail, right tail, or two-tailed test. Remember, we talked about if alternative hypothesis has less than sign, it would be left-tailed, greater than sign, right-tailed, not equal to sign, two-tailed test. Write down all the information from the problem. Find the critical values using the tables. So critical values again would be the z values, t values, or chi-square values, depending on the statistic you're dealing with. These are going to be based on alpha. Make sure you draw and shade the curve and shade the critical region. Next step is compute the test statistic. The formulas are on page 238. Next step, make a decision to reject or fail to reject the null hypothesis if the test statistic lies in critical region. Finally, write your conclusion. In the next video, we will talk about p-value approach.